In today's video, we will discuss stress in soil due to surface loads. When a vertical stress on an element A is sigma z, then it can be estimated by a simple formula of sigma z is equals to gamma into z. The vertical stress on element A can be determined simply from the mass of the overlying material. If represent the unit weight of soil by gamma and the vertical stress by sigma z, then the calculation will be gamma into z. Sigma z equals to gamma into z. In the given diagram, we can say a point A is situated at the z depth below the ground surface, and the variation of stress with depth we can see sigma z equals to gamma z at the bottom of the graph, and on the top most it is 0. It is varying between 0 to sigma z equal to sigma gamma into z. Stress in a layered deposit. The stress in a deposit consists of layers of soil having different densities may be determined as. This phenomena is also discussed in stratified soils, in which sigma z is equals to gamma 1 h1 plus gamma 2 h2 plus gamma 3 h3 dot gamma n plus gamma n into hn. It may be also written as the summation of n I equals to 1 gamma I into hi. For example, in the given diagram, we can see there are there are three consecutive depths h1, h2, h3, and all are situated between below the depth z1, z2, and z3, and the unit weight of soils in depth h1 is gamma 1, at h2 it is gamma 2, and h3 it is gamma 3. In such condition, we can calculate the sigma z1 as gamma 1 into h1. We can calculate the vertical stress at depth z2 is sigma z2 is equal to gamma 1 h1 plus gamma 2 h2, and at vertical stress at depth z3 we can calculate the effective stress by calculate the vertical stress by sigma z3 is equal to gamma 1 into h1 plus gamma 2 into h2 plus gamma 3 into h3. In this diagram, we can see gamma 1 into h1, gamma 1 plus gamma 1 into h1 plus gamma 2 into h2. When there is a surcharge on the surface of soil, in such case we can conversion land surface. We can convert the land surface into q equal to gamma h, and h is the depth of the surcharge and q is the intensity of the surcharge. In such case, the the effective vertical stress may be gamma into z plus q, and this q is gamma into h. Vertical stress has three components: total stress, which denoted by sigma; effective stress, which denoted by sigma dash; and pore water pressure, that is denoted by u. Vertical stress due to self weight increase with depth. There are three geostatic stresses which I have told you before. Sigma z into gamma z is the total stress, and this total vertical stress consider a soil mass having a horizontal surface and with the water table at surface level. The total vertical stress at depth z is equal to the weight of all material, that may be solid, water, per unit area above the depth. Sigma z on the total, we can calculate sigma z total is equal to gamma saturated into z. Z is the depth and gamma saturated is the saturated unit weight of the soil. What is pore water pressure? If the pores of a soil mass are filled with water, and if a pressure induced into the pore water tries to separate the grains, this pressure is termed as pore water pressure. The pore water pressure at any depth will be hydrostatic, since the void spaces between the solid particles is continuous. Therefore, at depth z, we can calculate the pore water pressure as U is equal to gamma W into Z. And this gamma W is what? This gamma W is unit weight of water, and Z is the depth of water. Effective vertical stress due to self weight of soil. The pressure transmitted through grain to grain at the contact points through a soil mass is termed as effective pressure, and this effective pressure may be denoted as sigma z dash is equals to sigma z total minus u, and minus u is what? This is the pore water pressure. Then we can say if we want to calculate effective stress of a given soil sample below some depth z, we can calculate sigma z dash equal to sigma z total minus pore water pressure. Stresses due to surface loads. When we consider stresses due to surface loads to analyze problems such as compressibility of soil, bearing capacity of foundations, stability of embankments, and lateral pressure on earth retaining structures, we need to know the nature of distribution of stress along a given cross section of the soil's profile. When a load is applied to the soil surface, it increases the vertical stresses within the soil mass. The increased stress are greatest directly under the loaded area but extend indefinitely in all directions. This is the end of the lecture, and thank you.